Okay, so here we are for the VCAA 2021 Maths Methods Exam 2, Section B. And in this video, we're looking at question 1. But before we get to that, a couple of things in the instruction box. So the second one here, all questions where the numerical answers required an exact value must be given unless otherwise specified. So unless you are told give to a certain number of decimal places, you leave it as an exact value, so surds and all the rest of it. Next one is the one under here. Questions with more than 1 mark, appropriate working must be shown. So if 1 mark, you can give the answer, but any more than 1 mark, there's got to be some sort of working involved. All right, so question 1 here is about this a sheet of cardboard making a box, and so we take the sheet of cardboard and we cut out some squares on the end, then we end up with a box. We fold it up, and so then the length of the box becomes like that, the width of the box becomes this one, and the height of the box becomes the X when we fold that edge up. So the length of the box is 2 lots of H that we're told here, minus that, so minus 2 lots of X. And the width of the box is this H here, minus that lot of X and that lot of X, 2 lots of X. All right, so if we come down to here, we've got this one here is 2H minus 2X. This one here is H minus 2X, and the height of our box there is X. All right, so then a box has to be made from a sheet of cardboard where H is 25. All right, so H is 25. Let's have a look at that. So the volume of our box, we need to show. So for show, even though what I've said before, you have to give 1 mark. You don't have to give working. With this, because it's a show question, you do have to give some working. So the volume of the box, of course, is the length by the width by the height. And the length of the box is this. Now H is 25, so that's 50 minus 2X. The width is H, which is 25 minus 2X, and the height is X. All right, so now what can I do? I can, from this first factor, I can take 2 out as a common factor, and then I've got 25 minus X. I've got 25 minus 2X. And I've got X out here, so if I then put it in the order that they've got it, then our volume in terms of X is 2X, 25 minus X, and 25 minus 2X. All right, so there's that particular one. Then what we move to is state the domain of the volume of the box, of V box. So the domain, that's talking about the X. Now, each of these things here, each of these terms, obviously, has got to be greater than 0. So the first one here, this X has got to be greater than 0. However, there is, so I'll write that down. So the first thing, X has got to be greater than 0. But then so do the other 2 bits, the 25 minus X and the 25 minus 2X have also got to be greater than 0. And the key one there is the 25 minus 2X. That's got to be greater than 0. All right, so 25 has got to be greater than negative than 2x if I add 2x to both sides, which means that x has got to be less than 25 on 2. All right, so my domain then is 0 to 25 on 2. Now, if x is one of those, then one of our terms is equal to 0 gives us a volume of 0. Now, of course, we can't have a volume of 0. And we're even told that in the information up the top up here, see, volume of the box is greater than 0. So we need curved brackets there and there because those two aren't included, but anything in between that. All right, find the derivative of the volume of the box with respect to x, and it's 1 mark. So we've got this here. So in this question, it can be handy to, if you define in your calculator, and you can just enter this in your calculator and ask it to differentiate that in your calculator. I'm not going to show you how to do that on your calculator. Get your teacher to show you how to do that. But when you do that, derivative of volume of the box, you get 12x squared minus 300x plus 1250. And if we were to factorise that, we can take 2 out as a common factor. 6x squared minus 300, not 300, taking the 2 out, so it's 150. 150x plus 625. All right, so do that on your calculator. Then for part D, calculate the maximum possible volume of the box and the x value which this occurs. All right, this is going to take a bit of working here. 3 marks. You haven't quite given me enough space here, I don't reckon, so I'll put a line down the middle. All right, so our maximum possible volume occurs when the derivative of the volume, so v dashed of the box, is equal to 0. So that's when this stuff here in the part C is equal to 0. So then that's a calculator job. So calc, and we want to solve in our calculator, solve where this expression is equal to 0. And when you do that, you get 2 answers, and have your calculator in standard, so because you're not asked the decimal places here, so we've got to give an exact answer. And so what you get is 75 minus 25 root 3 over 6, and the other answer is 75 plus 25 root 3 over 6. All right, so what we need to know, because we've got a domain of x up here, this one here, if we just, that ends up, and again, you can do this in your calculator, change it from standard into decimal, get a decimal answer, and that's about 5.28. And this one's about 19.71, all right? 19.71 is not in our domain. Remember, our domain is between 0 and 25 on 2, so between 0 and 12.5. So this one's not in the domain, so not in domain. So we don't want that one. So the x value for which it occurs, so the max vol when x equals 75 minus 25 root 3, all on 6. Now, the volume of the box, so our volume of the box, I can remember I said we can define that, and if you know how to use define and you've defined your volume of the box as this, you can now substitute that x value that we've got, this 75 minus 25 root 3 on 6, substitute it into that expression. And what you get is the volume of your box when you substitute that in. Get your calculator to do all the number crunching. What you get is 15625 root 3 over 9, and it's centimetres cubed. All right, because we know we were told, remember, that was 25 centimetres. Back up here, 25 centimetres. So the units would be centimetres cubed. Now you might need to get your calculator to simplify the answer for you. It may give it to you in a form that's a little bit clunky. All right, so this question bit here really relies quite a bit on you being able to use your calculator efficiently. All right, next. E, waste minimisation is the goal when making cardboard boxes. Percentage of waste based on the area of the sheet of cardboard. Before it's cut out, find the percentage of the sheet of cardboard that is wasted when X is 5. All right, so if H is equal to 25, then the area of our sheet, remember our sheet is 2H long, so that's 50 by 25, which is 1250 centimetres squared. All right, so when X is equal to 5, the area of the cutouts is, well, it's 5 squared because they're squares, 5 times 5, and of course there's one on each corner, so there's 4 of them. So there's 100 centimetres squared that's been cut out. Now we want to know the percentage of the sheet of cardboard that is wasted. So we know the area of the sheet of cardboard, we know the area that's cut out, and so the percentage waste is, the 100 is the waste out of the 1250, and to turn that into a percentage times by 100, and that comes out to be a wastage of 8%. All right. Okay, so key with that question there is to understand what they're wanting from you for that. All right. So then we move on to the next part, part F. And part F, when I get to it now, consider the box on a rectangular sheet where h is greater than 0, box's length is still twice its width. Let the volume of the box be the function that gives the volume of the box. Right, so what are they talking about? They're talking about a volume of the box, and we've looked at a box with volume, but we've looked at a particular value of h. We looked at it for 25. So now what they're saying is just leave it in there as h. So effectively what they are wanting is back here, when I did this back here, instead of putting the 50 and the 25, we're actually just putting these things here. So if we look at that, then we can get the volume of the box is the length by the width of the height. So volume of the box is the length, which is 2h minus 2x, by the width, which was h minus 2x, by the height, which is x. So now we want to state the domain of the box. All right, so our domain is what we're after, again, is related to the domain we found before. And so the domain we found before up here, whoops, was between 0 and 25 on 2. Now this 25 on 2, what's this 25? This 25 is this h. So now we're not putting h in there, we're putting, we're not putting 25, we're leaving it as h. So it will be 0 to h on 2 for that one. The domain is x is an element, still between 0, but now h on 2. All right, so this volume of the box bit that I've put here, that's not the key part for this part 1. Our domain here, that's what we're after for part 1. All right, now though, we are looking for the maximum volume of any such rectangular box. So now we're going through that same process that we did before, that v dash box equals 0. Excuse me. And now v dash of our box, we've got to differentiate this here. And when we do that, we get 12x squared plus 2h squared minus 12hx. And what we're looking at is where that is equal to 0. And so you can stick this stuff in your calculator and you can ask it to differentiate, and that's what you would get. And then when you solve that, get your calculator, solve it, you get two options, 3h minus root 3h over 6 and 3h plus root 3h over 6. And again, this particular one is not in our domain. So the x value that we're looking for is the 3h minus root 3h over 6. And so you'll notice that there's some similarities here with these expressions that I've written and these ones here. All right, because h is 25, 3 lots of 25. All right, and so on. All right, so then it's saying find the maximum volume of the box for any such in terms of h. So the maximum volume occurs when x is this, so we're just putting this x value into here. So volume of the box would equal to h minus 2 times this. And then you need to get your calculator to do all this crunching of all of this stuff. Then h minus 2 lots of that 3h minus root 3h on 6. And then, of course, times by x, which is 3h minus root 3h over 6. And you get your calculator to do that expansion and a simplification. And when you do that, you get that your volume of your box is equal to root 3h cubed over 9. All right. And again, there's a similarity between this volume and the one before. All right, so that's F. Now for G. Now consider making a box out of a square sheet of paper. All right, so out of my square sheet of paper now, my square sheet of paper, it's now H by H. All right, and we're cutting out X out of there. So this time our volume is again length by width by height. The height is X. The length and the width this time are the same, and they're H minus 2X. So V dashed, if you work that out, get your calculator to do that for you, is 12x squared plus h squared minus 8hx. And of course, maximum occurs when V dashed equals 0. And so you want to get your calculator to figure that out. And when you get your calculator to figure that out, figure out 12x squared plus h squared minus 8hx equals 0. You get two values for x. You get h over 2 and you get h over 6. Now, checking these, h over 2, if you cut out a half h there and a half h there, you've only got a h altogether, so you've cut the whole lot out. So that one there would not be in the domain of this particular thing. So the maximum volume then occurs at x equals h over 2. So that one there is not in the domain. All right. It's not h over 2, but I've said it's not in the domain. So I've actually said and written the wrong one after I've said that that's not in the domain. So h over 6 is the one that we're after. Sorry about that. Because h over 2 is not in the domain. All right, so there's question 1. Fair bit involved in using the calculator to get your answers and things from that. So make sure you know how to use your calculator. Get your teacher or one of your fellow students to help you with operating the calculator. You certainly need to be able to use your calculator efficiently in this particular question. All right, that's it for this video, just for that question. And so all the other questions in exam 2 section B have their own video.